Okay, we are going to start by drawing out the diagram and writing some equations that will allow us to solve this problem when creating the model. So we initially have a container open to the atmosphere and it's filled with 1 kilogram of water. So we'll go ahead and draw a container, water, and we know that there's 1 kilogram. Oops. So we know that there's 1 kilogram of water, and the contents initially at 298 Kelvin and 1 bar. So we have temperature initial. Why does it keep doing that? We have the initial temperature that equals 298 Kelvin, and we have the initial pressure 1 bar, and that is equal to 10 to the 5th pascals. So right there. And we know that the container is sealed and heated to a final pressure of 2 bar, which this is our initial pressure, and oh my gosh, okay, this is our initial pressure, and this is our final pressure. Why is it writing it down there? Don't understand. Okay, and our final pressure is 2 bar, so 2 times 10 to the 5th. I do not understand why it keeps doing that. 2 times 10 to the 10. Okay, this is not good. Okay, thank you. Please stay. Okay, so back onto the problem. We want to determine the final temperature and the total volume. So our two unknowns are our final temperature and our total volume. I don't know why I keep scrolling. Alright, so now that we have our unknowns written out, we can write out, oh, never mind, we actually have one more. We know that the moles of water in the vapor phase, we know that that's equal to 0.3. Oh my gosh, Christ. Yeah, that's equal to 0.3 moles. Okay. So we know that we have a final pressure of 2 times 10 to the 5th pascals. So we can set up a pressure equation. So we know that our total pressure, we know that is equal to the pressure in the air. It's very sensitive. Pressure in the air plus water pressure. Okay. So now we know that, and we know that is equal to the 2 bars, so 2 times. This is making it very difficult to explain this correctly. 2 times 10 to the 5th pascals. Okay. And we can set up from the PV and RT equation. So we know that PV equals nRT. We know that the N, so we have our N right here, so the moles of water in the vapor phase. We know that. Why does it keep doing that? I am very sorry. Alright, the moles of water in the vapor phase. We know that is equal to, we can set that could be equal to the pressure of water in the vapor phase. So pressure of water in the vapor phase. This is making it very difficult. So that's equal to pressure water in the vapor phase times the volume. I don't know why I keep scrolling back down. Times the volume of the vapor phase and then that will be divided by the R constant times the T. Oh, This is very frustrating. R times the temperature, which we do not know. So our temperature our temperature right here, as well as our volume, are two unknowns for this problem. Okay, so we know that our pressure of air and our pressure of water make up the total pressure of 2 bars. So we can define our pressure of air, not that, that's not air pressure. Everything is just getting deleted out here. Okay, remake that. We know that our pressure of air, we know that is equal to, wow, okay. This is making it very hard to explain without getting interrupted by these complications. Alright, we know our pressure of air and our pressure of water make up the total pressure. So we know our pressure of air can be said from the PV-nRT equation can be the moles. Can be the moles of air. I do not understand why it is going to be doing this the entire time I'm trying to explain these equations. But anyways, the pressure of air is equal to moles of air times, are you for real? Okay. You know, moles of air times the R, and then that times T, and then this can be all over the volume in the vapor phase. So let's go volume, vapor. Okay. And then we also need to add on the pressure of water in the vapor phase. So H2O, and then times the temperature. And then, like we said earlier, this would be equal to 2 times ten to the 5th pascals. Okay. So, on the contrary to that, we know that our moles of air, we know that that is equal to, from the PV-nRT equation, the moles of air is equal to initial pressure times the volume in the vapor phase divided by R times the initial temperature. Okay? And we know that from this equation that the volume in the vapor phase has to be equal to the total volume minus the volume of water, because the volume takes up is water and air. And we know from this equation that the volume of water in relation to the density we can figure out, because density is the mass divided by volume. We know that the volume has to equal the mass of the water divided by the density of the water. Be very slow with these before my screen scrolls down again. Okay, so taking this information, we can go ahead and write one last equation that relates the volume of vapor to all this and how we can determine the final temperature. So we just determined that the volume of vapor was equal to the total volume minus the volume of the liquid, which was the mass of liquid water divided by the density. So from this equation, the volume of the vapor, we know that the moles of our water in the vapor phase, we remember that that was 0.3 from the equation. Oh, see, scroll down again. So remember that that was 0.3 from the initial problem. And we know that from the PV-nRT equation, this has to equal the pressure water times the volume, pressure times the volume in the vapor phase, which is this right here. And then we know that that has to be divided by the R gas constant and the R gas constant multiplied by, this is very frustrating, multiplied by the final temperature. So that will equal, that will be our last equation we will set up, and then that will help us to solve for our two unknowns.